So problem is consider the function g of
Sir, 30 to 40 students are waiting in the general channel, sir. Like they have joined in general.
okay. So I have to leave this one and join there.
Tell them to come here.
Yes, sir. So tell someone to go and he will told them.
So where the is CR is present here? Just wait. Five. So I have been created. Okay. They are leaving actually that meeting and coming here. Wait for it.
Yes.
That will write the problem.
Good morning, sir.
Morning. Still few students are in there. Okay. So as we know that to find out the closest point, we have to consider the distance between the arbitrary point which is close to your origin. So the distance function d square is comes to be your x square plus y square plus z square. So we can consider consider that d is equal to under root of x square plus y square plus z square. X square plus y square plus z square, and subject to the condition that z equals to your 1 by xy. So if we replace this value herein, we are getting this one to be your some function f of xy is to be d square is d, which is your x square plus y square plus 1 by xy its whole square. So for this one, it is hard to differentiate. We need to find out that the critical points. So for that, we are considering this f, which is your whole square of that. That is your d square. Now, what is your f of x? So therefore, for critical points, that f of x equals to 0, which is your comes to be 2x. The differentiation of this one minus 2 by x square for gives you x cube, that is y square. And f of y equals to 0, which is equal to 2y minus 2 by x cube, x square, y cube is this. So now if you're going to evaluate these two things, so these two expressions, that is we can get this two expression is equal to, so therefore 2x equals to, therefore 2x square is equal to 2 by x square y.
Once.
Yes.
Okay, sir. Thank you, sir.
Okay. So 2x square equals to your 2 by x square by y square, and 2y square is equal to, and we have that 2y square equals to 2 by x square y square. So if we could find out that could we find out that x square and y square in that terms?
Sir, it is 2x is equal to 2 by x square.
2 by x cube y square. So that x we are multiplying. So that gives you 2x square equals to 2 by x square y square. And again y we are multiplying. So that gives you 2y square equals to 2 by x square y square. So therefore we are getting that.
Yes, sir, right,
Plus
sir.
or minus 1, plus or minus.
So therefore x is equal to, or x square equals to y square. This implies x equals to plus minus y. So if you have that x
Sir, 1
equals
by
to,
y square. 1 by y square.
No, plus minus by. Is equal to plus minus by.
That's right, sir.
Right, sir.
Right, sir, right.
now we need to find out that the value for your x exactly. So we should have that expression. What do you have it? Your 1 by xy, this one, this equation, that is 2 into x minus 2 by x cube y square equals to 0. So we have that x equals to 1 by x cube y square. This implies x to the power 4 y square equals to 1. Now y is your plus minus x, so that is your x to the power 6 equals to x to the power 6 equals to 1. So that gives you the possibility that x cube square is equal to plus or minus 1. So therefore x cube square is plus or minus 1. So therefore the values for your x, sorry, not x cube, is your plus or minus 1. So therefore the values of your x is comes to be plus 1 and minus 1, because remaining values are comes to be your complex. So the possible values for your x is plus 1 and minus 1. Now for your x is plus 1, we can have that y is plus 1 and x is plus 1, so y is minus 1. So for each values of your plus, y has its plus or minus 1. So therefore there are 4 points. Therefore the critical points are your 1 1
1 minus 1
minus 1
minus 1 1
minus 1.
minus 1.
These are the 4 points. Now you can see that in this case, for all the points, you're getting that the value of your f of xy is to be your 3, because you have that f of xy is your x square plus y square plus 1 by x square y square. So all these are the positive, and that gives you the value to be 3. It will not be less than that of it. So therefore now, and also if you increase the value of your x and y both, then the value of your f of xy will goes larger. So therefore we can say that f of xy is greater than equals to 3 for all x and y. So therefore we can consider that the point which is your the minimum value for that f of xy is comes to be your 3, and since this one is your minimum value, so therefore with the help of these points we can find out the value of your z also. So what are the points then? Therefore z is equal to 1 by xy, and that is equal to your the points come to be so therefore the points come to be, if you consider that 1 1, then we have the points 1 1 and 1. If you consider the point 1 minus 1, then it comes to be your 1 minus 1 and minus 1. If you consider the point minus 1 and 1, then also your minus 1 1 and minus 1. If you consider minus 1 and 1, then you have that minus 1 and 1. So these are the 4 points which are your closest to the origin. So therefore these points are closest to origin. And the minimum distance we can find out, that is f we have taken to be the square of that distance quantity. So therefore the minimum distance is comes to be is equal to under root of 3 from the point to that one. If we can solve another one.
Sir, one doubt.
Yes.
Sir, in which question do we use Lagrange's multiplier, that lambda thing, and in which question we do not use? Sir, that is one doubt.
If the surface is given, and that surface you could separate, means you could write down in the explicit form for z equals to f of xy, and that will be fruitful to you, you can apply that Lagrange's multiplier, means you can apply this rule. Okay, otherwise if you are getting that you could not be separate those two things, then you have to apply that Lagrange's multiplier. We will solve that problem also with the help of your Lagrange's multiplier.
Sir, like ma'am gave one question in
Yes.
which a point was given and a circle was given, and it was told to find the minimum distance. So we did it by Lagrange's, but now that you have shown that we can do it by normal method also, so that is why one confusion occurred.
No, either of the process you can follow, there is no issue, but because the problem we are going to solve here, you can apply also the Lagrange's method, that will also give you the same thing. But sometimes what happens, to find out exactly the points, too much difficult. So it is better to shift it into the means 2 variables, then you can find out all these things. But also on the other side, if you are getting much more points and it is difficult to find out what the minimum value is. By intuition, we are getting that the functions are in such a way that x square, y square, and 1 by x square, y square, all these are positive. So we can conclude. But suppose you have the function being your x and x plus y and plus 1 by x square, y square, then it is hard to conclude about that what will be the minimum value, because here we can see that if we increase that of your x and y, then the values of your f of x y will goes larger. Okay. So and the function f is also not being your defined at the point origin, because this of x square and y square is in the denominator. So therefore for such case we could find out that the minimum distance is of your means minimum distance could be find out with the help of this function, but all the time we could not be find it out. So that time you must have to use the Lagrange's method. You can apply the means by these general rules. If it is possible, then it is okay. If it is not, then we must be go for your Lagrange's method.
Okay, sir.
Sir, can we do this problem using Lagrange theorem?
You can go with that of your Lagrange's method. But the thing is, if we can solve it without your any Lagrange's method, then why not we solve it? So I'm saying you that first you try. If it possible, then if it is okay. If it is not possible, then you just use that Lagrange's method.
Okay.
Rectangular solid of maximum volume can inscribed sphere is Q. Okay. So just you consider the giving you the hints. I think you can solve this one. You consider the solids sides to be your rectangular solid, that is 2x, 2y, and 2z. These are the length of the sides. So therefore the volume it comes to be V, which is your 8xyz. Okay. And it is this such a volume, if we inscribe in the sphere, then that should be your cube, and for that we need to show that x equals to y equals to z. So therefore here the condition is comes to be your x square, the sphere is comes to be x square, y square, and z square is equal to your r square. The r is the radius of the sphere we consider. So for the maximum volume, which is constraint under this one, so we can see that V is the function of x, y, z under the constraint. We can consider it to be suppose V, so we can take it to be phi of x, y, z, which is equal to x square, y square, z square minus r square. So for such case, if you are going to find out that z in terms of your x and y, so it comes to be some difficulties or lengthy. So rather than if we use the Lagrange's multiplier, it will be helpful. So we just construct one function, that is f is equal to v plus lambda into phi. So for the critical point, we need to consider that the differentiation with respect to x, y, z and lambda. So that is your fx equals to 0. F of x equals to 0, which implies your Vx plus lambda phi x equals to 0, which is your Vx means your 8yz, lambda, this is your 2x equals to 0. Similarly, we have that Fy. So you have again that the same thing, that is Vy plus lambda phi y equals to 0. That comes to be your 8y means xz plus lambda into 2y, and that is Vz plus lambda phi z equals to 0, which implies your 8 z means yx or xy plus lambda 2z equals to 0. Now if you are going to find it, another one is your phi f lambda is equal to 0. F lambda equals to 0, which gives you, that is your phi x y z equals to 0, that is x square plus y square plus z square minus r square equals to 0. So now if we multiply this first equation by your x, this one with your y and this one with your z, we get that these three expressions will be equal. So that gives you 8 xyz plus lambda into 2x square equals to 0. Again we have that 8xyz lambda into 2y square equals to 0. 8 xyz lambda into 2 z square equals to 0. All these things are same if we divide by your 2 lambda also. So that 3 gives you your x square equals to y square equals to z square. All three are the your square, so that must be implies your x equals to y equals to z. So it represents you a cube. If we can so. If yes.
Sir, how the 8xyz plus lambda 2x square is come?
Lambda 2x square is?
They come, sir, where?
From this equation, if you multiply this by your
x, both side.
Ah.
X, Y, Z multiplied with
You just multiply this equation by your y
X, Y, Z. Yes, sir.
and this equation by z. These three equations.
Sir, in the starting point, you have took that 2x comma 2y comma 2z, right, sir?
2x. Which one?
Sir, in the previous slide, yes, sir. 2x comma 2y comma 2z.
These are the length of your rectangular solid. These are the length of.
It is mentioned, sir.
No, we consider that one. We consider that one because that is of your rectangular, so the lengths are not equal. Okay, length of sides.
Sir, what is R, sir?
R is the radius of the sphere.
Okay.
Sir, if I took x comma y comma z is also fine, or wrong?
X comma y comma z is also fine, but the thing is that the equation will comes to be reduced, that is x by 2 and y by 2 and z by 2, and also this will be also reduces. Then that time you have the volume is x y z, and then also it will be whole.
Yes, sir, got it. Yes, sir.
I think it's more problem. Find the extremum. The extreme values. Along the circle. We consider here along the circle, okay, of radius 1. And center is at all. So we need to find out the extremum values. So again we consider that by your Lagrange's method. So here your f of xy is your x square minus y square, And under the restriction that the points we are taking for finding its extremum value is your phi xy and it's of your circle. So we can consider that phi xy equals to x square plus y square minus 1. So that is f is equal to f of xy plus lambda of phi xy. We need to write it down. So therefore for the extremum point fx equals to 0 equals to fy and f lambda equals to 0. So fx equals to 0 gives you f of x, that is your 2x, and this is your lambda of 2x, that is plus 2 lambda x. 2 lambda x equals to 0. You have that fy equals to 0 minus 2y. Then you have that plus 2 lambda y. And the third one is of your x square plus y square equals to 1. Problem is we need these three equations to find out the values. So I'm writing again, that is 2x plus lambda 2x equals to 0. Another one is 2y minus 2y plus 2 lambda y equals to 0. Another one is equals to 1. Now we need to find out the values for your x and y. So from the first one, if we consider this equation, then we have that is your 2 1 plus lambda into x equals to your 0. So from here we can consider that x equals to 0. So one possibility is x equals to 0, and if you consider that x equals to 0, or what's that? Plus lambda x equals to 0. So for that x equals to 0, we can have that y is your plus minus 1. Y is your plus minus 1. And what about that lambda? And that time lambda is equal to your minus 1. Okay. So if you consider that lambda equals to minus 1, that comes to be your minus 2y minus 2 minus 2y and minus 2y. So that I'm wrong.
Plus 1 becomes lambda.
Lambda comes to plus 1. If you consider that plus
Y
1,
into
that comes to
lambda
0.
minus
Yes,
1
yes,
is
yes.
I is plus minus 1, but sir, after plugging into an equation 2, that is minus 2y plus, the y will come as minus 1. So plus 1 will get omitted.
lambda plus 1.
Yes, sir.
So because we have to satisfy whole three equations and then only we'll get the
We must have to satisfy whole three equations.
Then it will be satisfied at 0.
No, sir. If both are 0, then third equation doesn't.
So y is equal to
Lambda
minus
becomes
1, sir,
plus
only,
1,
sir.
sir.
So
Lambda becomes
Yes,
plus
sir.
1,
X
then
equal
it
to
is
0,
positive,
y equal
sir.
to minus 1, lambda equal to minus 1.
Sir,
Both
but
the equations are satisfied.
Okay. You just
yes,
wait.
sir.
First, we consider that these two things. So we are considering here either x equals to 0 or lambda equals to minus 1. Both the things will not be considered as a simultaneous. We can consider one at a time. So for x equals to 0, we are getting that y equals to plus minus 1. Now we are going to find out the lambda value from this equation. Let's see what is going on. Then it will be clear to all of us. Okay, so for that one, if you consider that y equals to 1, we are getting that is your minus 2, that is your minus 2, and plus that is why we have considered plus 1. So plus 2 lambda equals to 0.
Lambda plus 1.
So lambda comes to your 1. Okay,
Yes.
so if lambda is equal to 1, then also we don't have any problem because we have taken that x equals to 0.
Yes.
Another thing is that if you consider y equals to -1, so y for -1, it comes to your +2 to
Then also lambda equals to 1.
2 minus 2
2
lambda.
lambda equals to your
Yes,
0, so lambda equals to 1. So therefore, in either case, we must have to consider that lambda equals to 1. Is it? Now we consider the another criteria for your. Is there any option? If we choose that,
Sir, y equals to 0 we can take.
we can now consider that y equals to 0. That's good. From this equation, we can consider that this equation can be write it down as of your 2 into 1 minus lambda whole into y equals to 0. So if you choose that y equals to 0 again, so for that y
Sir,
equals
lambda -1, sir.
in this case lambda equals to -1.
No, sir. 2
No,
into
sir,
lambda
lambda equals
-1.
No. Oh, lambda -1. So we are just
Lambda
multiplying by
-1.
minus. We are just multiplying by minus.
Okay,
Is it? You can write down that lambda -1 also. So for y equals to 0, then we have x equals to +-1. So for that x equals to +-1. So for your x equals to +-1, what the criteria is that if you consider that x equals to 1, then we can get that lambda equals to your -1.
-1.
-1, yes, sir.
So lambda comes to your
Both the cases -1 only.
-1.
Yeah.
Yes. So therefore, what we are getting, so the critical points are now comes to be your 0 plus minus 1, and therefore critical points are 0 plus minus 1
Plus
and
minus 1, 0.
plus minus 1 0. 0. Now we consider the values for your f. So if you're going to compute that of your f, so f of xy, it is equal to x square minus y square. So if you consider the case for your x is your +-1 and 0, I'm writing both at a time because this is your square, so that is your 1. Every time it comes to 1, which is your positive. So at this point, you have the maximum value. This gives you the maximum. And f of 0 plus minus 1, which is equals to every time is your -1, which is negative. So that gives you the minimum value. Okay. So these are the extremum values for that function at the critical points. We could be find it out. Okay. Now we can solve.
Sir, for this maximum and minimum, is it safe zone to check the double partial derivative also, no, sir? Or what?
No, in this case, we don't need to be checked for your double derivative. We can conclude that the functions has its maximum and minimum depending upon the values of that function.
Okay, sir.
In previous problem, we are finding a point which lies on the circle and satisfying that equation also, x square minus y square. What we are doing in the previous problem, I didn't get it. What basically the question says.
You have to find out the extremum values of your this function along the circle of radius 1 and center is at origin. That means you have this function, you are going to find out the maximum value which are the points lying on this your circle. Okay, so you have that circle at center is at origin. So you are considering according to this extremum points, we are getting that the 4 points which are lying on here, and these are. Now some of the points for that function we are getting the minimum value, and some of the points we are getting to be your maximum value. That's the thing is. For such function, if you are restricted that it has its extremum value, that means what we are saying that the function which has its your not only a single or discrete critical points, it has its your infinite number of critical points that time.
Okay, sir.
Maximize the function. subject to constraint. X square plus so I think you can solve this one by your own way, because again we can construct that of your function f, which is equals to f plus, if we denote this all by your phi, then lambda phi, and then take the differentiation, that is your fx, fy, fz and f lambda, all them make is equal to 0. Therefrom here you will get the points which will satisfy that these four equations, and at the points we need to be compare the values from the first point and the points we are getting at different critical points we are getting. Then we need to be find out what will be your means at which point we are getting the maximum and which point we are getting the minimum. Therefrom we can find out the maximum value. Okay, which point gives you the maximum and which point gives you the minimum. Therefrom we can get the maximum value. So you can maximize that function by with the help of your Lagrange's multiplier. Okay, so I'm not solving this one. I'm giving you one more problem to solve you. Here we can write. Find the maximum and minimum of
Sir, the
yes.
solution of previous problem is root 2.
That's right, root 2. I can give you the points also. That
Yes,
is
sir.
your 1 by root 2.
Lambda equal to plus minus 1 by root 2.
Yes.
Yes, minus 1 by root 2.
Minus 1 by
0. Z is equal to
Minus 1 by.
These are the
minus 1 by
points,
root
and
2.
you have to compare which points we are getting
Yes,
the
sir.
maximum value. Yes. X,
Yes,
y,
sir.
half of x square. Square region. Equals to 1. It is the D is the region that we are considering to be this one. So again, we also consider that is all the points. If you are getting any points in between of that, then those points also considered to be. Okay. So with this and one more problem, you can try. Let's find the maximum, minimum, and saddle point. And maximum.
Show the previous problem once again.
Just wait.
Yes, sir. Please, sir.
Yeah, I'm coming. Of z equals to the power minus 2. We will get a series of points in this case
E to the power minus x square plus y square by z, sir.
by 2.
By 2.
Yes.
Sir, show the next slide.
तो इस नीचे वाले क्वेश्चन में हम ये कंसीडर कर सकते हैं कि जो भी मैक्सिमम मिनिमम वैल्यू होगी वो क्या बाउंड्री पर लाई करेगी.
No, it could not be always like to be on your boundary. It can be also lies in between of that also, because we have considered in this case the region is. Okay, so if you're getting any points which is inside of that region, then also you have to consider. But lastly, we are considering the points which are is exactly on the boundary.
So, sir, what will be the approach to solve this question?
By the same process, we will consider that is equals to your means lambda into g of f of xy, and we consider that time is equal to 0. Okay, so I'm not starting today the gradient divergence and line integral, Carl and line integral. Next class we will do that. Just wait there.
But that was half x square plus y square less than equal to 1 now.
Yes, yes, yes. Okay, so thank you all.